Hello fellow engineers and welcome back to Poly Bridge 3. Today we're going to be creating some of the world's most iconic bridges in Poly Bridge 3 and seeing how each one works and whether Poly Bridge 3 allows them to stand tall or fall like an architect. Okay, so let's head into the sandbox, and I haven't really touched the sandbox too much. I mean, I did beat the world land speed record in here, but I haven't actually built any bridges. So first off, we need a theme. So I think for this one, rocks will do. Yeah, that looks sort of where we want to be. But that span, it's only 12 meters long, so we need to expand it a long old way. Perhaps we can try and go for 100-meter span, although it's not quite 100 meters, and you'll see why in a second. So let's get building. For this first bridge, we're going to be needing the foundation, which is Poly Bridge 3's brand new material. And so essentially, I'm going to be splitting this span into 3. So I think we probably want to do like that there. Then if we copy that over to this side, what square is it in? 1, 2, 3, 4, 5. Gotta love the background grid. Makes things nice and easy. So there's our foundations. So that's where our bridge will actually come out of the water. And this is going to be the biggest clue for what this bridge is going to be. I'm going to select the red steel material because essentially that's what this bridge is mostly made out of. So if the road is going to be like that level, I think we'll do that sort of thing and then just copy that up lots and lots of times. So next up, we actually need the road. So I'm going to use the line tool, but I'm going to do a slight bit of a curve. So we go from that point over to that point. We don't put that much of a curve in. We just want a very, very small one. So if we do something like that, and then this is going to be the world's longest. Ooh, I'm out of breath now. But that is our road in. Next up, I think I just want to copy this road down, actually. So we go down probably about that far. And then we don't actually want road on the bottom. We're going to be replacing that with steel, which could take some time. And then we're just going to want to cross brace all of these up. So I'm literally going to do that. And then I'll come back in the other direction. So it's a proper cross brace. So that's going to support the road, sort of. It sort of means the road has a bit more strength and it shouldn't snap. Of course, though, shouldn't is the key word here. I feel like this is a lot of bridge for Poly Bridge 3 to handle, and it's a very, very long span, 100 meters. But yeah, I'd imagine from now you've probably guessed that this is the Golden Gate Bridge.
Really?
Which is a huge suspension bridge. And I feel like, to be honest, I probably need to cross brace these as well, because these pillars, they're going to be taking the entire weight of all that material you can see. So that looks pretty good. If I copy this, rotate it to the other side, then we're sort of nearly there. We just need to put the cable in. Now for the cable, this is the most essential part of a suspension bridge.
Oh, really? Is that so?
Because basically all the weight of the road beneath, it hangs from these cables. So if we go for something like that, then what we want to do, each of these nodes, we just want to draw straight up using the grid and then just connect like that. So basically you can see this road and truss is going to hang from the wire above. Then this bit gets a bit tricky because we're sort of overlapping. So I think what I'm going to do here, I'm just going to hang from the top pillar itself. But with those in, we can then join them all together. I'm going to try and use steel. I imagine this is just going to break completely. But the actual bridge, it is cable. It's just like painted red. If we copy that to the other side, join them together, then you can sort of see how this is going to work. Because if you imagine all that weight in the middle, it's going to pull down on this wire above. But obviously at the moment, it's only connected to this tower. So the towers are just going to fall to the right. I mean, I can probably press play. So if we watch in super slow motion, you can see as the weight of the middle pulls down, it pulls the two towers inwards. And that is because we are missing a fundamental part of this bridge. The other side. So what I'm going to try and do is grab this cable, copy it, and shove it over this side. Yeah, now you can see with the curve how much higher it is. So instead, we'll draw this curve again. Now, I've added an anchor point down there just to hold the cable in place. But we basically just want to do what we did before. So we've drawn that. We just do the straight up cables. So we go from the road straight up to where the wire meets. And we connect them with steel, which only just reaches. That's why I haven't used steel as the vertical cables, because they've got a length limit in this game. It looks like they just about work here. We'll probably have to replace them with cable to get the actual strength. Assuming this will even work without turning unbreaking on. But yeah, let's copy all of that to the other side. Boosh. And then let's see how much of a disaster this is going to be. Oh yeah, no surprise there. Completely fails. So if we watch this in slow motion with the stress on, you can sort of see it's just so much weight coming down these cables. Because think about this, the entire bridge, all the road, all the cables, it's all coming down this force here, down this pier. And you can literally see that at the bottom. It just goes bright red. And then these bottom pieces just absolutely obliterate. I wonder, actually, if I were to try and make these stronger by using, like, muscles, I imagine it will end up that all the pieces are going to need replaced with muscles. Yeah, because that's the next one that's gone. So, again, we'll muscle that. All right, so that... Oh, that's working a lot better. The bottom cross braces are then going. So what if we could make this even more muscly by doing that? So, oh, you can see the stress. It sort of went through, but then it survived. Okay, so where's the next broken piece? Oh, it's over there. What's it doing over there? I'll tell you what, let's just replace all of that section with what we've done over this side. But yeah, we're sort of at the point where you can see that road there just absolutely pops. And that might be because there's so much movement in this. So I'll tell you what, let's just delete this entire tower and then replace it with a new mega muscle version. Now it's worth noting the road under here, it's not actually connected to the pillars. Like, the only way the road is connected to the pillars is through the cable on top. But right, with those in, let's see, is that any better? Oh, it's definitely holding together a bit more, but not a lot remains now. So what you broke down there? What are you doing breaking? Okay, so I made a little tweak down there. Let's see. Oh, this is getting close now. This is actually getting close. So what actually broke was just the road and a few little bits of steel. Okay. I'll tell you what, I should probably disconnect that. Because essentially, bridges in real life, they have an expansion joint. Because bridges, they're designed to move. Like, if you try and make something rigid and it wants to move, it's going to break. If you allow it to move slightly, it will be a lot stronger. I think what's happening, this road is trying to stretch a little bit. So if that wasn't connected, if we just had our road going to like there, and then I just move it fairly close, I can do that, cable it up to the top, mirror that to the other side, and then I think the road's going to be less inclined to snap. Oh, God. But the rest of the bridge... you could argue more so inclined to snap. If we go back to having these connected, I mean, there's so much movement in this bridge. I'm not sure we're going to be able to do this. One other thing we are definitely missing on this bridge, it's the cross braces. That's probably making all the difference. Now, the only way to get cross braces in this game is to use road. But if we just road across all of these, then suddenly we have a much more realistic looking bridge, except the road is still getting annihilated. Oh, and that extra weight has made everything break. Oh dear. I shouldn't laugh, I'm an engineer. However, if I were to use my engineering brain, we can just come down to here, pick that, and then we should be able to add a load of vehicles, as well as some boats and planes. And then we have the Golden Gate Bridge recreated in Poly Bridge 3. Yes, didn't quite work as intended, but we were close. We got close, I think. So comparing it to the original, there we go. I'd say we did a pretty good job. Although one of the harder ones to get right in the game, no doubt. Anyway, for the next bridge, we start a brand new level again. We need to make this quite a big span. I think we'll just go 80 meters this time. Again, we want a curved road, but this one is a lot taller. So we'll... Oh, what happened? Trace abort... What? What do you mean trace aborted? I said... Oi! What's going on here? Boo! Yes, it's working. Boosh to the end. Right, so that's all that done. And then how this bridge compares to the one before. This is a cable-stayed bridge, which a lot of people get confused with a suspension bridge, but they're very, very different. And I'll show you why. So let's just find where the middle is. So I've just marked the middle there. All right, and then for this one, we're going to be using the foundations. Oh, which don't go tall enough. What if I bring the sea level up a little bit? Can I raise foundations then? No, okay, we're going to have to lower the bridge a little bit. Right, so for this one, the ends of the bridge are sort of on foundations. So we can literally just do that, which should mean the majority of the bridge is very, very strong. And essentially our span just goes from there over to there. So it's a lot shorter. However, for this next section, we're going to need 2 foundations as close as they can go together. I guess sort of like that. And then we're going to have to build a pillar with this because we're going to be doing a cable-stayed bridge. All right, so we'll build the pillar and then I'll show you how a cable-stayed bridge works compared to a suspension. So essentially you have a pillar in the middle, which I haven't built yet. I'm going to have to build that afterwards because of how this game works. But essentially the road is supported by going up to the cable. And you want to go sort of in a 45-degree angle. So if we just go from each bit of road up to where our pillar's going to be, then we end up with this. Then we can do like a straight across line, just so we can mark out where the cables go on the opposite side. Essentially, we have that. We'll then just cross it up to make it a lot stronger. And then we take our cable from the pier down to the road, which means you end up with this sort of thing. And if you remember the suspension, that had a cable that sort of went along like that, and the road hung from that cable. On this one, we're connected directly to the pier. And the easiest way to explain how this works is by trimming it down. So imagine we've only got that bit. When we press play, you can see the cable is holding up the road on either side. So if we add another bit of road, we just stack the same thing on top. So when we press play, again, the road is just hanging from the cable. Ignore that guy. And so essentially, as long as this is symmetrical, as long as the weight on the right matches the weight on the left, then that is how a cable-stayed bridge works. The cable helps the bridge stay in place. So now we just want to copy that, mirror it onto the other side. And then we have our next bridge, Tampa Bay's Sunshine Skyway Bridge, the beautiful cable-stayed bridge, allowing our police car to get to the other side. And if we turn the stress on while we watch this, let's slow the speed as well. You can see where all the force is. It's at the bottom because all the weight of the bridge, of the car, everything, it's coming down this pillar. And obviously, the lower down the pillar, the more weight there is from the weight above. You can sort of see as well. Can you see like that side goes red, and then as the police car goes onto the other side, the other pillar goes redder. That just sort of shows how the weight is moving. So the pillar's moving left, then it's leaning right. That one's leaning left, then it's leaning right. Very small amounts of movement, but they do make a big difference when you're designing bridges. So that is 2 bridges I've done. I've got one more for you. And this one could be one of my favorite bridges. I did actually build this in Poly Bridge 2. And if I remember correctly, it did actually work. So it'll be interesting to see whether it does work in Poly Bridge 3. But for this one, it's all about adding terrain, because I'm trying to make a huge gorge. So essentially, we just duplicate terrain and then just keep going down like that. Then once we get to just over halfway, then we start making the drop a little bit shallower. So we want to go a bit wider than we are dropping down. So we end up with something like that. The question is, can I copy this to the other side and save a lot of time? Bum. Well, okay, I'll just move all these manually by hand. Right, and then we end up with something like this, and you can see school bus, he's got to get to school. Oh my goodness.
I guess I'm being spontaneous.
But unfortunately, river at the bottom. Hence, we need to build a massive bridge across here. So first off, let's grab my favorite tool, go across there. I feel like on this one, again, I do probably want a very, very small arch. So I reckon something like that will just boosh into place. And then we're going to be using steel for this because this is going to have to be a very, very strong bridge. Now, the road isn't going to be strong enough as it is. So like the Golden Gate, I'm going to have to truss underneath it. So I think if I just copy that, go straight down to there. And then, as before, replace the road with steel. We then want to add cross braces under here. So basically, we're just doing an under truss. So that's all that done. I will just cross brace so we got the force being spread along more axes. Then we copy that to the other side. Now, obviously, if we press play, that just collapses. But this is why this is one of my favorite American bridges. We're going to build a huge arch underneath to support the road above. So the best way of probably doing this is, I think, if we support every other beam. So I'm just marking these with a bit of steel. So 1, 2, 3. I think this third one, if we go straight down, I think that's where our arch is going to start from. Same on this side. So let's just shove some anchors down. So I want 1 for that bit, probably there, 1 down there, and then this is going to be where the arch starts. So I'll probably need 2 down here. So I guess I'll do something like that. And then I'll do the same on this side. So then if I just delete all these markers, we should be able to draw our arch from that point over to that point. And then if we just raise it up to like there. Oh, that is exciting me. That is exciting me. Now, before we build our arch, we're going to have to connect the bridge pieces to it. So I'm going to start from this side. I'm just going to do muscles from all of these down to the anchors that I just did. So we got those in place. To go down to this one, you can see it's going to be way too tall. So we're going to have to use what I like to call mega muscles, which is essentially doing that sort of thing, just allowing our muscle to reach. We should be able to go every other road and then connect vertically down to the arch. Right, nice. Then you can see our steel pieces, they won't actually reach across there. I mean, it will reach on that one, but it looks like we're going to have to go like every other and then truss this up in order for it to reach. So I'll just go to the middle of each one, do the same down this side. We're marking with the cables. Then we're drawing the top of the arch in steel. Then we can finally remove that. And then we should be able to get our arch in now. So if I go from there, how far roughly is it to that point? 0.63 meters according to that. So what I reckon I'm going to do, I'm just going to come down 0.63. 0.63. 0.63. I'm trying to be perpendicular to the arch. Right, then if I do another curve, and then I should be able to go through my markers to try and make it symmetrical. So something like that looks good. And then I think what I want to do, rather than going like straight down on every one like that sort of thing, I think I actually want to do like a truss to the middle. So I want to do that sort of thing and then just connect all of those together. I think this will be a lot stronger way of doing this. So after trussing all of this up, we end up with a massive arch like that. So all we need to do now is replace these marker cables with steel muscles and mega muscles, depending on how long they are. So down to that one, oh, I think we can get away with just a muscle. So may as well just do a muscle because it will weigh less. So I think we'll just go along doing this. If we don't need a muscle, we'll just do vertical pieces like that. But then we end up with this. And now I haven't actually tweaked these. Like all these muscles, they're pretty messy and stuff. But oh my God, it works. It works. Oh, stress is going up. Stress went to 99%, I'm pretty sure. Oh no, something popped down the bottom. But it worked. Okay, that was honestly really, really surprising. Let's try and neaten this up a bit. All right, so that's made the bridge lighter. Is it as strong? Oh no, look, that bit popped down there. I assume the same is going to happen on that side. Yeah, okay. Yeah, so if we watch this with the stress on, you can sort of see like the stress is the very bottom of the arch. And then as it goes over to the middle, it swaps to the other side. So yeah, it's just those bottom two pieces. So I reckon if we just replace those with muscles, then the new River Gorge Bridge is completed. And comparing it to the original, I think I've done a pretty good job there. Considering it works legitimately as well. No unbreaking needed. And it's an 80-meter span, remember. This thing is huge. So yeah, one of my favorite bridges in the world. Although not as well known as some of the more famous ones. Absolutely love this one. Everyone say hello to the Wheel of Bridge Tune. Get it? It's like fortune, but bridge tune because it's about bridges. Right, never mind. Let's click it and we'll see where it ends up. But you're not going to see. You're going to have to guess where it lands. Right, so this first bridge is a 395-meter span bridge. Now, in this game, I think you can only go up to like, 250 meters, but I don't even think you can build a bridge that long without it falling. Maybe that's a video for another time. But yeah, this bridge is from the 1800s, and it's a Portuguese bridge. Now, for this bridge, it's actually a double-decker bridge, which means we're going to need 2 bridge decks, so people will be crossing high up and low down. So I've gone for terrain sort of like that. I'm just putting some anchor points in. But yeah, basically, this is connecting like 2 sort of cities with a river in between, and the cities are sort of quite mountainous. Hence, we're going to have people like down here, as well as people up here. Wow, I'm putting these vehicles in. I've just realized how big I've actually done this. Anyway, we'll start building. I'm sure it'll be fine. So first off, as I said at the start, we need 2 lengths of road. So the first one connects there to there. And then the second one connects from there to along there. And then I do actually need to lower the sea level a little bit. It's not actually that high. I was going to say just to make sure some boats can fit underneath, but all the boats in this game are really, really tall. What happened to the little boats from the last game? I'll tell you what, we'll shove some low-flying planes under there. I'm sure that'll be fine. If anyone asks, they're boats, okay? Anyway, a couple of things I need to do here. I just need to use some cable to sort of mark where I'm going to build things from and to, etc. And so essentially, I just need to support the top with a truss. So if I just use wood for now, I basically just want to do like that sort of thing. If you've watched any of my videos, you should know what a truss is by now. It's basically just a load of triangles. And everyone knows triangles are the second strongest shape. So with those in, we then need sort of support piers. We've got to basically do like this sort of thing. So I think I'll do them in steel so they're longer. So that goes down to there. I'll copy this to the other side. Add some anchors for that pier because there are pillars there like that and like that. Okay, next up, this bottom bit of road. It also has a very, very small truss. So again, we'll truss that up on top. Trying to keep it flat, Matt. And then you might be wondering, well, Matt, how is this bridge going to get a strength? It does not look very strong. If you press play, yeah, I mean... It's catastrophic. Oh, silly car. And this is where the power of the arch comes in. So let's grab an arch. We go from this point here over to that point. And then we've got to curve it up so that the top sort of merges in. In fact, we can probably go, yeah, to those nodes. That looks good to me. Right, so I've then filled that in with wood like that. I will just mirror it to the other side so we can see what we're doing. Because we then need a second arch under here. Because basically we're going to make like a trussed arch. So like our trusses up the top, we're just going to be connecting triangles between these. So we want that sort of shape. So you can see it's wider at the bottom, thinner up the top. Generally bridges do that because you don't need as much strength in the middle. Because obviously the outer edges, they're taking the weight of the middle. Whereas the middle is only going to be taking the weight of like itself. But what I'm going to do, I'm going to go from each of these. I'm going to go straight down with steel like that. So that we end up with something like this. And then if we just connect all of these together. Boosh, 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 boosh. Copy it to the other side. We end up with that. But you'll notice, look, we've got squares. And squares are not strong. See? So we need to add our triangles into this. But what this bridge actually does, it makes sort of a third line in the middle of these arches. So if I just add extra anchors to this pier down here, then we can draw a curve between these two, trying to stay directly in the middle the entire time. So I reckon something like that, to be honest. And then this is where things are going to get trussy. So essentially, we go from either corner to where it meets in the middle. And then not only that, we also go from these to actually meet halfway along these. So they're going to be like almost like little Union Jacks. Maybe that's why I'm so excited to actually do this bridge, because it makes me feel really British. But essentially cross like that, then just connect them together. And then once you've done all of them, you end up with a truss like that. Now this arch should be pretty strong. Whether it will hold the road above, I mean, technically it shouldn't because we haven't finished this bridge completely. I feel like this road beneath will fall as well. So, oh, it held the road above. Will it? Oh, no. It sort of collapsed with that car on there. However, you did see that arch stayed in place. That's because this arch is very strong. So essentially, we just do what we've got here, these little vertical supports. And we just place those along the bridge that rest on the arch. So this road above is being held up by this arch. So if we just support from the arch up at regular intervals, we get that. So hopefully, as this guy drives across, you can see that is now supporting, although we've got level failure. Now that's because this is the part underneath that needs supporting. So similar sort of thing, and that will just go straight down. And then in the real bridge, they do use trusses, but I mean, I could just use cable because it's only going to be in tension. It's only going to be hanging from this arch, but that's basically how this bottom bit of road stays up. So if we press play, ooh, it seems to be working. What's the stress? 85%. No, it works. It does work. Decent. Anyway, if you are Portuguese and you haven't guessed this bridge yet, let me just color it in with a different material so it looks more true to real life. So here it is, the Dom Luís I Bridge, a Portuguese double-decker steel arch beast. And I colored it all in hydraulically, and I regret it because it took ages. But look, it works, and it was under 500 grand. Not bad. Thanks for the suggestion on this one. However, because there are hydraulics, I'm going to be doing something quite sacrilege. We'll go back into the blueprint. We'll then come to here and turn on unbreakable. And then we're going to add a hydraulic phase to go before all the vehicles go. And then when we press play, oh, wow. Okay. Will the bridge still work?
Nope.
I mean, technically, if I just gave these guys loads of horsepower, here, have some horses. And they might actually have the strength to get up. Oh, I did a backwards roll. Oh dear. Right, well, anyway, let's go on to the next one, which means back to the wheel of bridge tune. So we'll go again and see what we get this time. So we're on to the next bridge, and this one is made out of steel. It's from the same era, actually. I'm not going to say where it's from because I feel like that might give it away. I will tell you the type of bridge, though, because they're not too common these days. It's a cantilevered bridge. Now, before we get to the cantilevered bit, I'm just going to do the start, which is essentially using foundations, which are locked at that height. So I guess that's going to be the height of our bridge. But basically at the start, we've got 4 foundations. So we'll plop those in. And then using red steel, these are literally just cross-braced in place, which means we have that a nice simple little truss. And then we get to the cantilevered bit. Now, these have foundations at the bottom, but I'm not entirely sure of the scale of this until I start getting some lines on the page. But yeah, the total length of this bridge in real life is 2,400 meters long. So obviously you cannot do that in Poly Bridge, so trying to do this to somewhat of a scale that's suitable. Okay, so let's start off with the 2 foundations. They sort of sit at water level there. Then we've got our 2 roads and we're supporting them with steel. And then we just build like a big structure around it. Next up, the reason why this is a cantilevered bridge is because basically you build out from the middle. So you sort of make a cantilever, meaning you build on one side and the other. It's balanced. So if I build the frame like that and then we just truss these together by basically just doing a cross beam like that, then another one there, we can see these 2 lines going from corner to corner. They intersect down there. So I've just got to move this to cross that. And then we've got our brace. So if I copy that to the other side, mirroring it, then when we press play, you'll see it's completely balanced. We can turn the stress on. You shouldn't be able to see anything, basically. But if we were to build out one side and not the other, then the bridge would it would be a lot weaker because there'd be more weight on this side. So the entire structure would try and lean. Hence, you build both sides evenly. So again, intersection point there. We can do the same on this one as well, which means we end up with that. And I imagine at this point, a lot of you are probably guessing what this is. I don't know. Maybe you're not. Maybe I'm just a bridge nerd. But connecting this to the main line, we just do that with that bit of road. All right, so then we end up with the huge cantilevered pier. And then from those, oh man, I need to make this level a lot bigger. It's going to be way longer. But basically, there's one of these with a little bit of road in between. And then we just want to connect another one and another one. So we end up with that. We now need to make sure that these bits don't break because, look, they're not supported by anything at the moment. So these are literally just trussed very simply like that. I mean, they're actually I should probably do this legit. They sort of have mini trusses. So let's do a little baby truss. Okay, so we just copy that across all 3 spans. Then at this end, we do the foundations with the under truss. Add a big old truck because whilst this is actually a road bridge in this game, it's a rail bridge in real life. And I feel like that's probably the closest we have to a train. So here it is, the 4th rail bridge in Scotland. One of my favorite bridges, actually. It's just so much steel. It's so long. I mean, it's everything you want from a bridge, isn't it? And if we watch this with the stress on, we can sort of see, like, as it goes to either side, this side's going red and that side will go red because remember it's cantilevered. So as this is pulling over that way, these middle piers, they're sort of leaning left and now it's going to be leaning right. Really cool bridge. I'm very surprised it worked first time, like no issues at all. What does the stress actually go up to? Right, we'll keep an eye on that. It goes up to, 69%. Nice. But yeah, thanks for recommending the 4th rail bridge. You gotta love a Scottish bridge from the 1800s. But let's get on to our next bridge. So another spin of the Wheel of Bridge tune. What we'll land on, you guys won't know. Okay, so for this one, we're heading to Denmark. And if the Danish bridges are anything like their bacon, I'm very excited about this one. So we're gonna make a very big I feel like actually, should we go all out? Should we go? I mean, I'm gonna try it. I'm gonna try and go as big as we can. 250 meters. Because in real life, this bridge is 6 6.79 kilometers long. That's 22,000 feet for you Americans. Now, I won't lie, I feel like chances of making this work legitimately slim to none. However, I'm gonna give it a go. So let's go from there with a curve all the way over to here. Now that's a bit high of a curve, so we'll bring it down. And the curve's sort of only in the middle. I don't know, if we do that sort of thing, and then I would do the boosh thing, but it's... We're going to be all day. Look at it go. I could be booshing all of those. But that's a lot of booshing. That's a lot of booshing for anyone. That costs 75 grand, just the road deck. All right, next up. Oh, look, there's a modifier. Unlimited foundation height. Yes, that is what I need. Because basically, I think I want to group like... perhaps 3 bits of road, then grab another 3 bits of road, and basically do little sections like that. Because this bridge is sort of made up of like 2 different parts, well 3 different parts, like the 2 edge pieces and then the middle section. So I'm doing the edge pieces now, and basically with these, I think I can just grab a foundation and just wang them on those, and that should support everything above it, I hope. So let's press play and see. Oh, yes. Yes. Okay. They are supported. That is good. So we'll do the same on the other side. And annoyingly in this game, you can't actually mirror foundation. So I can't just use the copy paste mirror thing because we've got foundations already stuck in. So I'm going to have to do this manually by hand, but it won't take too long. Right. So we got 10 piers on either side, which will support the road. But then we need the bit in the middle. And you might be wondering, well, Matt, why don't they just make bridges where like you just have these pillars all the way across? Well, generally it's because we got to fit big old boats underneath. And look, if we go grab a big old boat, you'll see pirate ship fits under the bit in the middle. But look, the ship's so wide, it can't get through the pillars. So that is the reason we're going for. Anyway, for this part of the bridge, the middle part, like the Golden Gate we did last time, this is a suspension bridge. And to give myself the best chance and to make it actually look a bit more realistic like the original, I'm going to be using a material in here called the pillars. But first, I think I just need to mark out like exactly how wide this is. So that is the middle of the bridge, definitely. So the span to there is 65.5 meters. Presumably it's the same on the other side. Yep, 65.5 meters to there. Okay, that's good. So now I just want that 65.5 meters to be in the middle. So I've marked on where I think I need these pillars. So I'm basically just going to do as tall of a pillar as I can. I can only get away with 12 meters, but thankfully I can just duplicate and then shove it up. So we'll duplicate those to the other side, get rid of our crazy cables. Oh, and actually I've just realized this is a suspension bridge, not a cable stay. I was sort of designing it as a cable stay. See, it's very easy to get confused. Remember, cable stays are the ones that sort of do that sort of thing. So they have lots of parallel wires. And basically the cables they pull on either side just to keep this up straight. But no, we are doing a suspension bridge, meaning there'll be a cable coming all the way across like that. And then we'll be hanging from it the road underneath. So what I might want to do, just give myself a little bit more room, essentially. So let's move these back. Then what I'm going to do to give myself that best chance, I'm going to shove anchors up the top. And then I want to dangle my cable down the middle. And this goes pretty low. So sort of like that. So they're all going to be joined by cable. But first I need to suspend the road from them. So I want to click the road and then go vertically straight up. Now, it's worth remembering, because this bottom one is curved, it's not going to be snapped to the grid. So I've got to try and use like my cursor in the background to get it as perfectly straight as I can. So then we end up with that. So we can just cable between all of these. Remember, all of this is cable because all of this is going to be in tension. Every piece is going to be pulled apart. Like, none of it is going to be compressed, which is good because cable doesn't work in compression at all. If you try and squish a cable, you're going to be... well, it'll be like trying to squash a bit of spaghetti. Not going to happen. Anyway, for this section of the bridge, the cables up here actually drop down to like these huge anchors. So what I'm going to try and do is draw these with a custom shape. It's basically just a huge concrete triangle which sort of goes like that under the water, but it's got like a big hole in it. So I'm going to have to make sure the behavior's on static so it won't go anywhere, and then add an anchor up there to it for the cable. Then we copy it to the other side, and then we should be good to go. I mean, pretty much straight. I mean, we probably need a bit of a sag on it. But since we've sort of cheated by doing the anchor points in the middle like that, it shouldn't matter too much. But generally, like the cantilevered bridge, you would want to try and mirror these as much as possible, just so the weight was even and this pillar doesn't fall over. But as before, vertical cables up, and then connect the tops of all these cables together to the top of the pier. And then if we just copy this to the other side, add a couple of cross beams. These are definitely legit. They're not just visual. And then if we press play, it all collapses. No. Okay, so what actually broke? It's that wire up there. Presumably just because there's so much weight from it. If we watch this in super slow motion with the stress on, we can sort of see as gravity starts taking effect. Yeah, they're just getting stretched. So I think essentially there's just way too much weight coming down that cable. So question, what if we were to replace these with springs? You can see the spring. Oh, the spring just got stretched. Yep, they snapped. Okay, it's worth a try. The other thing I can do is try and replace these with like cable muscles, which essentially just makes like, rather than having one cable there, we got two cables there. And you can see I put a little bit of wood in the middle just so that that gets compressed. The cables get pulled apart. So you should see, yeah, they were stronger. It was the cables lower down that broke. So I guess we do the same thing. And ideally with these muscles, you want to try and make them symmetrical. So if I leave the original cable in and then do that sort of thing, bring them nice and close, get rid of the cable in the middle. So I'm going to go through and replace a few of these with the cable muscles, generally just starting from the top, because obviously the higher these are up, the more force that's going to be put through them. Because like these top ones, they're taking the weight of all the lower ones. So you can see I've replaced the top 5 or 4 pieces. So let's press play. We're on super slow motion. So let's just see. Oh boy, 98% straight. Oh, it's okay. It's held. It's held. Somehow it's held. Right, let's turn the speed back up. Oh man, the bridge is shaking like anything. That is not the wind. There's no wind in this game. But yeah, you can sort of see now, like now it's rest. I mean, I probably should have done this first, if I'm honest. I just don't really know how I would have done it. But if you were to take a cable in your hand and just like sort of hold it out in front of you and let it dangle in the middle. So this pillar is your left hand. That one's your right hand. You got the cable doing that. It will fall in like a natural position. And that's what we're looking at now. And you can see underneath the road, because that is sort of, it's got like weird humps in it. It's all lumpy. That means I didn't do my cable in the natural hanging position. And therefore the road has sort of like, well, it's adjusted, shall we say, for the road. Oh, I've also realized as well, oops, you can't drive over that. So slight tweak. I guess I'll just bring that down. Okay, so now if we press play, oh, it works. It works. It's actually working. Okay, got to get a vehicle. This nearly cost £1 million. Where does the stress settle in the end, actually? Somewhere between 60 and 70%. So I'm not sure how much strength this will actually have to take a vehicle. But let's try with a school bus. I mean, the younger generation, they're much more like nimble than us. So they should be able to take any pain that we throw at them. So it looks like these first bits are fine. I might turn the stress on for this so we can see how it works. That is going to snap. Oh, there it goes. Sorry, kids. Right, but a small tweak and it's made it to the middle span. Now, this is the big span where it could all go wrong. The highest stress should be when it's in the middle, but actually seems to be okay. We've actually done it. You can see the journey is a bit rickety. It's not the flattest bridge in the world, but it's made it. It's made it. The kids are getting to school. Sorry, kids, again. Yeah, in case you're wondering, this is the Greenbelt in Denmark. I would try and read the Danish name, but it's something like Storeb&aeltsbroen Bridge. How did I do, Danish? Did I butcher that name?
Sounds great.
Hopefully I made up for it by making a very, very sexy bilf, in my opinion. It does actually look pretty similar to the original, mostly because of these piers. I absolutely nailed them. But more importantly, it worked. Now, for this one, we are heading to the United States of America, and this is actually, of the bridges that remain, the second oldest steel bridge in the US. And this is in a city, so it's a fairly urban bridge. So the way this bridge starts is it's on a little bit of a curve. I mean, to be honest, it looks like it actually curves like uphill. It's a bridge that climbs uphill, sort of like that. Hang on, let me just turn the grid on, and then I can line this up so it's completely tangent to that top. Nice. Though, to be honest, I may want to move that back a bit. And then here, add some foundations. Because once I push that road into place, shove a foundation there. And I think I just want to do like a sort of similar curve over that way. Push. I mean, it's actually supported by like a single girder, but you can't really do that in this game. So we'll just do a little truss like that underneath. Okay, then in the middle, we have another foundation like that. So that's sort of our main span. We've got another span of the same length. And then if we just move this to the right a bit, shove a foundation there, wang the same truss underneath, then we're almost ready to go. But before we put our main part in, we need to come into the blueprint menu. We've then got some pillars we need to add. So we need to cover these foundations with pillars and then make them, I guess, sort of 5 meters tall, and then add an anchor up the top as well. So then we just duplicate that over to this side, add some rocks to support the foundations, and then we're probably at the point where you can start guessing, because as I build this, some bridge experts / American people may recognize this, particularly if you've ever been to or near Pittsburgh. A place absolutely full of bridges, I might add. But yeah, we're going to be building in hydraulics, although there are no hydraulics that we're going to actually be moving. But let's just do that. I want to copy that to the middle and one to this end as well. And then I want to grab my curvy tool, go across to there, and then curve that down. I think I actually want to unlock tangents. I think the curve sort of works like on a horizontal plane, if that makes sense. But anyway, I can try and make sure we're bang on in the middle. All right, and then I've realized these are a little bit tall, so I will have to move these down probably 2 grid squares. All right, so basically we end up with a U shape like that. So if I take pieces straight up to intersect with that line, then just make sure all these are stretched out because we want them to be blue. Yes, you may call this architecture, but that's just how it is. We're then left with that. So we now want to do hydraulics between all of these down to these bottom pieces as well. Again, make them all do that so they're blue. Then we want to try and copy this road to the middle. So we end up with that. We can then replace all of these with hydraulics as well. Then we want to do the straight up supports like we had underneath. And basically what we're trying to make is something called a lenticular truss bridge, where we sort of end up with a lens shape. So we sort of just need to grab all of this, copy, and then flip horizontal, flip vertical, and basically bung one of them on top. Now, because this is on a curve, I've made it very, very tricky on myself. I can't just copy that. But I reckon it's probably close enough to start with, and then I can just tweak afterwards. So if we turn the grid off, remember we got to move only vertically for most of these. But that's not too bad. However, you'll probably notice this ain't going to be very strong because there's lots of squares, meaning all these corners can move. I mean, if I press play... Oh my goodness. Yeah, if we watch from the front angle, check that out. So yeah, we do need to add the cross braces. And so I'll do these in steel to start with, just so you can see like where they go. But basically, they're just going between all these. Now, because they're so tall, we're going to have to line tool, fill in, and then move that down to meet there. I mean, actually, I should probably do that with the first one as well. But essentially, if we go through and do that for all of these, then we end up with that. And then when we press play, look, now it supports itself because the power of triangles. So I'll now go through and just make all of these blue. And then we're pretty much there. We just got to do the other truss. And I won't lie, I wish I didn't do this on the curve because I can't just copy that one annoyingly. But after a bit of jiggery pokery, we have finished the bridge. And so you can see this is a 2-span one. You see each sort of disc looks like a lens, hence lenticular truss. And let's just add a, I don't know, Pittsburgh. Is that like, I feel like that's probably lots of trucks and stuff, right? But yeah, we'll add that and then we'll take a look at the final bridge. So there it is. And this is the Smithfield Street Bridge in Pittsburgh. Built between 1881 and 1883. And yeah, as I said before, still standing. It's one of the oldest steel bridges in the US still. Let's have a look at this with the stress on. Oh, wow. Look at that bit in the middle. You are very stressed, mate. So if we slow this right down, you can sort of see how the force is distributed. So mostly it's along these curved parts. Now this top piece will be acting in compression because it arches up as the force is pulled down. It's basically all these pieces are going to be crushed together. Whereas underneath this curve is going to be acting in tension. This piece in the middle, it's so red. I think that's because Well, basically, the entire weight of the left and right bridge is being crushed as that's sort of smashing down into this foundation. But yeah, as we speed up, you can see the forces. As we get to the middle, they're going to be the most force on these end pieces. But oh, that bit failed. My bad. And before we go on to the next level, let's just come to modifiers. We'll turn on Unbreakable. We will add a hydraulic phase at the start. And then when we press play, oh my goodness. Can our truck still make it across the bridge? Fair play. It is going for it. Okay, it got stuck. But let's just watch that again. It's like something out of Nightmares. Like the really jagged movement was terrifying. Anyway, but yeah, cool bridge, that one. Shall we move on to the next one? So I've loaded up the Wheel of Bridge Tune again. Let's give it a spin and see what we get this time. Except you won't. Okay, so this is going to be a cool one. We've got to get right down to sort of water level. And again, sorry other nationalities, but we are back in the US for this one. There's a lot of bridges in the US.
So he's a racist. That's his problem, not mine.
Okay, and the way that this one varies from others that I've built is it's a moving bridge. It's actually a lift bridge. So rather than a drawbridge that sort of works by like doing that to go up, a lift bridge, so you got your two spans like that, a lift bridge, the middle bit actually lifts up vertically like that. And anyone that's been following my Poly Bridge 3 campaign playthrough will know I'm not too good at the old movement. Anyway, for this, I'm actually doing shorter bits of road than usual, just because of how the trusses work on this. Okay, so annoyingly with this one, I am building this out of hydraulics just for the color again. But since there is movement, we are going to actually have to move hydraulics, which means I'm going to probably have to use the hydraulic controller and tell all of these not to move. Otherwise, it'll end up an absolute mess. Anyway, I need another foundation to go there. And then from this point is where we build our sort of lift part. So we sort of build a straight up truss like that. And then because this is going to be taking the weight of like a road in front of it down here, the supports do lean back a bit. Well, actually, they look pretty spot on, don't they? Yeah, we can just fill that with road. So we end up with that. Next up, we need to add our split joint. So we press J on there. But first, I need a hydraulic phase. So that needs to go before the car goes, and another one after. All right, so then on the split joint, I want that disconnected. I then need to build a truss under here for the actual bridge. Then I can just copy that across like that. And then there's sort of a little blob like that. So that wants to be connected to that little one too. Okay, so if we press play, you can see that drops. Oh my goodness, I haven't fixed those yet. So in the hydraulic controller for phase 1, I basically need to untick all of these hydraulics. Actually, let's just remove all. That's a lot easier, Matt. We'll do the same for that one as well. But we do want that joint to split. So now when we press play, you can see the bridge drops in the middle. Perfect. If I do a straight line from up there down to there, I can then slide this to get lots of pieces. And then go boosh. So that's now filled with loads of hydraulics. And they should work. But if we make this even on the other side, so let's just move that over there a bit. You want to copy that, flip it to that side, bung it there. Just make sure everything's connected properly. Add foundations in. And then in the hydraulic controller, we can say, all right, I want all of you to move. All of you on this pier as well. And then exactly the same on the one after, so it should come back down after it goes up. All right, then I'm just going to cross brace all of this stuff, just because there's a lot of trussage going on the real bridge, and I want this to look exactly as it looks in real life, whilst hopefully working. So the real test, if we grab a boat, what shall we shove in? It's going to be a steamboat coming. I don't actually know if this will go high enough, but basically the boat needs to go between the two hydraulic phases, then the car goes at the end. But if we press play, you can see how this works. So the car goes first, gets across. Then the hydraulics come up, which lifts the entire bridge deck up. And then, oh no, that boat's too big. That boat's too big. Thankfully, there is a scaler, so let's make it a bit smaller. So we'll just add a few of the extra bits and bobs in here. Do a bit of that. Say boosh. All right, and then there we have it. The Portage Lake Lift Bridge. which is actually called the Horton-Hancock Bridge because it connects the cities of Hancock and Horton in the US state of Michigan. And this bridge usually has a clearance in the middle of just 4 feet above the water, but when the middle bit lifts up, it goes to 100 feet. That's 30 meters. Now, this is actually a double-deck bridge. The bottom used to be a railway, just a single track. But that was abandoned in 1982. And this opened in 1959, by the way. So yeah, pretty cool bridge. I probably didn't do the actual like mechanical stuff how you're meant to, but whatever. I mean, it works. I definitely didn't have to shrink the boat for it to fit underneath. But yeah, I like that one. Really cool. Different sort of bridge to build in this game as well. I like it a lot. Anyway, let's spin up the wheel of bridge tune one more time. Let's go. Okay, so for this next one, we are heading to Mexico. Yeah, and I do actually remember seeing something about this when it was like made. I think it was made in, hang on, let me just look. Yeah, it was finished in 2003, and there were some controversies around it because it spans a river. However, the river is dry most of the year. Now, generally, this is a complaint that people that sort of don't understand how anything works. Because it doesn't matter how often that river does actually have flowing water in it. It's the fact that it does have water in it that we need to avoid it. Otherwise, our roads will be washed out throughout the year. And then you won't be able to drive to the supermarket or wherever you want to drive. So I've got some terrain in. So you can see we got our little river down there. Annoyingly, this monster truck does actually make it most of the weight. Although apparently it went underwater, so the level is failure. Therefore, bridge required. But since it's another cable-stayed bridge, but it's a bit more architectural, shall we say. So what I was thinking, perhaps I will draw the pier in a custom shape. Now I can turn off collide with vehicles so that vehicles can drive past it. Can I decide what's that? Oh, that's thickness. Okay, I can say how thin I want it. So let's just do 1 meter and let's just have a look. Ah, it's nice and thin. And cars drive straight through. Okay, that's perfect. Because I think what I want to do, I want to have this around here. Now, if I come to edit shape, I can add a pivot point. So if I add one of those in the middle, then look, it now pivots about that point. So therefore, I can try and turn this into a cable-stayed bridge and sort of show you how the wires work on this, keeping the load even, keeping the bridge hopefully upright. So for the color, this is just like a reinforced concrete block. So we'll go with something sort of concretey. And then anyone that's Mexican or perhaps knows Mexican bridges, they'll probably be able to guess from this point exactly what I'm doing. So I'm not actually going to have this touch the ground. So this bit isn't realistic, but the rest will be. I just want this to like show how a cable stayed bridge works. So hopefully, yeah, that still spins round without touching the ground. Okay, that's good. So we basically want to take this node and go way up here. And we add another node sort of perpendicular, like that sort of thing. Add a curve down this edge. So we end up with something like that. Now, if we do that, you can see it does just fall over. Now, let's just move this to the right a bit. Okay, so if you haven't guessed it from this point, adding these 2 bits may do, because basically we're adding a circle in here, presumably to make it a bit lighter, like in terms of weight, but also could be for architectural reasons that I'd rather not go into. So we got a circle in the top end. We got another one down here. I mean, that's not actually the perfect circle, but I'm an engineer. I work in triangles and 90-degree angles. But now we are ready to go into the build mode. We can grab some road, do what we love to do, which is draw a line between there, and then say... And then we are ready to add some cables to make this thing stay up. So first off, I need to add to this shape some joints. So one needs to go straight up from this anchor point. So if I just follow that up, we can shove that there. All the other ones go on this front edge and they just go straight down in cables to hold the road up. So I think what I probably want to do is go from like the furthest cable. And then with the grid off, just do loads of parallel cables. Although they're not actually parallel, to be fair. Yeah, from looking at the photo, I think what I need to do, I need to space them along this edge evenly. So if I just take like a block of wood there, I can then just copy that down loads of times. That will give us the spacing. So basically I can just add joints to this custom shape along the spacing that I've done with the wood next to it. So then we got this. So if we press play, everything will fall. However, if we then link via this anchor up to this cable and then go from here over to that piece of road, then what you should see happen, yeah, look, it's holding itself up. Oh, I've just realized where I've made it thin. The nodes are floating. That's a bit strange. Still, we can then just go from each of these nodes holding the road up. Then if I just support this bit of road under here like that, because remember this goes all the way through to the ground, so it does actually touch the ground. So I can do that without it being cheating. But the way that this works is if that cable wasn't there, I imagine all these cables will pull this to the right. Even though it's leaning left, yeah, can you see the weight of the roads? It pulls this thing up and to the right, so it flaps over. So this cable anchors it down. So as this is trying to rotate to the right, the weight of that pulls on this cable, which is being held in place by this anchor down here. So when we press play now, oh, it actually holds. It actually holds. And the monster truck gets across. Oh, did you see the stress there? Oh, man. 99.81% stress. Let's actually watch that with the stress on. So I imagine it was all in this cable. Yeah, can you see this is going redder and redder and redder? Because basically this is acting as a lever arm. So in order to get this to pull the tightest, you just need to go as far away from it as you can to get a bit of moment. And moment is like the sort of rotational force, and you work that out by doing the force times the distance to the rotational point. And remember, I've got my rotating node in the background there. So that's a nice little test of how that works, because you can literally see this force is getting higher and higher. There's a number down the bottom as we get further along. Nice, but in reality, this bridge is actually huge. So I may just scale this car down a little bit, just so it looks like, yeah, it looks way bigger now. Okay, so now time to butcher the name of this. This is the Puente de la Unidad, a cantilevered cable-stayed bridge in Mexico. And although it is a sort of product of architecture, it's quite nice to see like how this actually works like in the game and prove some engineering concepts. So that's quite cool. It's a shame that you can't like tell the cables to like come narrower, because that would look a lot better. That is the downside of building these bridges in Poly Bridge. So for this bridge, we're actually heading to Budapest. And this bridge, it has quite a long span to be fair. Although surprisingly, it's actually the shortest bridge in Budapest center. So I guess Budapest has lots of long bridges. That's all I can take away from this. Anyway, we'll attempt to do it at a scale where we're doing 40 meters. The actual length is 333 meters, but that will be impossible in this game. Anyway, to start with, as always with a lot of real life bridges, we need a bit of a curve. Because that adds some strength, it helps with drainage, all that sort of stuff. Because if your bridge is flat, the water's just going to pool on it, and you don't want that. So we'll go boosh to fill that with road. Then I'm going to turn the grid on.
You monster!
I know, controversial, but I need to put these foundations in sort of at a point where we've got a large span in the middle. The middle would be 20 meters. So yeah, we want to go 10 meters. So let's try one there and then another one there like that. So now our large span is split into 3 smaller spans. Obviously the middle one is a bit bigger, but you should hopefully see why in a second. So I'm going to build this out of hydraulics purely just for color. Yeah, but really it's just made out of steel. So basically where these pillars are, we have diagonals. So let's turn that grid off and bring that down and wang that in and that in. And then we should be able to lift that up a little bit. I just want to go vertical like that, because basically these are going to be the longest pieces in the bridge. So if I just copy that, mirror it, wang it on this one over there, then all I need to do is grab the line tool, go from there to there, but then go downwards like that sort of thing. And then to be honest, I feel like I need to change the road. I need to add more road almost. But essentially, if I just go from there vertically straight up like that, remember to extend the hydraulic just so we got the color right. Yes, you can call me an architect for that. Then we just go straight up from all of these nodes like that sort of thing. Then with those in place, we do the diagonal from the top left down like that. So that's how the trusses work on this one. You don't make triangles like that sort of thing. You just go from the middle pillar to the center of the bridge, and then we connect all these together like that. So that's made this half of the middle span. You can then do the same coming this way. I mean, actually, I'm probably going to need, let's add another anchor up there, add a cheeky pillar up there as well. Then we can do our curve in the other direction like that. That looks pretty good. I mean, it sort of looks like a suspension bridge, but it is all truss. There's no cables on this bad boy. But again, we go straight up. I mean, technically, we should go like perpendicular with the road. But that's the one thing that always sort of confuses me, trying to do these small scale realistic bridges. Because you always have these curves in, but like in real life, the perpendicularness, you can't really see it because the scale is so big. Anyway, same thing in that we do our truss from the top to the bottom left. So we're always heading away from these middle piers. Then we can connect all these top bits up, extend all of these so it's blue. Although this bridge is actually green rather than blue. Anyway, now we've got, you can probably tell this is slightly in the wrong place. Is that on a grid? Oh, it is on the grid. Okay, that's good to know. So we can bring that down to like there-ish. And then the final bit of truss work is just sort of like just a bit of underneath support. So almost like that. So yeah, something like that looks pretty good to me. So then I just grab all of this, copy, mirror, wang it on this side. Then quickly connect the middle with a cross brace like that. And then we're nearly there. We just need a little bit of decoration. Yes, unfortunately, this bridge does have architecture built in. So we've got a cross beam under there, which I'll do with road. Then we have a sort of pointy hat thing. Now, what I might want to do is sort of, if I hide them there, I can probably use cable just to hold that in place. And I can lift that up pretty high. Yeah, that looks good to me. I mean, these are just products of architecture, so I don't need to think about them too much. But there we have, it's the Liberty Bridge in Budapest. Yeah, built in 1894. Although it was rebuilt in 1945. Presumably it got bombed in the war. And after a quick Wikipedia, yes, it did suffer heavy damage during World War II. But I quite like that one, aside from the bits of architecture on the top. I don't really know why there's sculpture built in. But this is a cantilevered bridge, so much like the fourth rail bridge. All right, before we move on to the next bridge, we are going to do what I love to do. We go to Unbreakable, we add a hydraulic phase at the start, and then we press play and we see what the bridge does.
I am a scientist. It's so cool.
It's growing. It's growing. Okay, so that is the bridge. I cannot see the car making it across in the slightest. Question though, if we swapped it for Matt and Paddy in the G-Wagon and we crank up the horses to all the horses, surely Matt and Paddy can make it through this. I know it's quite a steep hill, but oh no, too much horsepower. Oh, Paddy, Paddy was driving. That's why. A very cool bridge. Thanks for suggesting that one. Anyway, it's time to go back to everyone's favorite wheel, the Wheel of Bridge tune, and let's give it a spin and see what we land on. Okay, so for this bridge, we're heading back to the US, but this doesn't actually exist anymore. It's been replaced with something new. Yeah, and the new bridge is actually more of a build than the original, but it's similar to something I've built fairly recently in this series. So I figured I'll try and build the original version, and perhaps we can see why it got replaced. But basically, this spans a huge gorge, so I'm going to need a bit of terrain just to sort of make the steep walls. I'll do a little bit of that. And then up this side, we'll do some more steep canyon walls. So that looks pretty good. Hopefully, I've actually done the span at a span. I can actually build this, if that makes sense. But I think if we put the road in first, we should be able to work backwards from there. So, boosh. That's the road in. So that's 55 meters. So the middle is like 27.5, about there. So half of that is about over here somewhere. Because this bridge is also a cantilevered bridge, which means I can probably do this with the grid on. But it'd be nice to try and build this as original as possible. Oh, actually, we're off grid. We're off grid. Hang on. I'll have to just boost by hand. So yeah, when I use the line tool, it doesn't do the max length. It just like makes it fit. So I do actually have to move my gorge over a bit. Thankfully, this is Poly Bridge and not real life. I mean, to be honest, looking at this, I feel like my gorge is going to have to be massively increased in size anyway. Unless, yeah, what I might do, I might sort of half scale this. So if I do my pieces that long, yeah, I think that will actually work way better. Oh, and it reaches over there. Nice. Okay, so for the pillars, let's just sort of mark on. I'm going to start doing the pillar here. So we do 45 degrees down to that point. Then we go straight up there. We meet in the middle, and that should allow us to go straight up like that as well. Okay, cool. Then we can copy that mirror, shove it there, and then that is the basis of our pillar. We then just want to go from that point down to that point, that one down to that one, and we can move these down a bit. Okay, then I need to work out how to do the cantilever bit. By the way, this will be quite a tall pillar. I just want to make sure we're at the right sort of scale. Because the thing with Poly Bridge, your steel pieces can only be that long. And I am about to need to go from down there. Is it all the way up to there? Oh no, there is middle point. Okay, I think we're good actually. I think we're good. Let's build the entire pillar all the way down first then. So basically we go straight across, but then we're doing another 45 degrees down to there. Then we're going straight up to intersect. And we want to delete that and replace with 2 so we can intersect that underneath as well. Then we can just copy a mirror. Always copy a mirror if you're trying to build symmetrical stuff. Makes it way easier, a lot less work. All right, this is where it might get tricky because then this continues all the way down. So 45 degrees is there. Do we reach straight up? Oh, we do, just about. That is on the limit of being to scale. Nice. Okay, from that point, we do a middle and then we go down again. So we end up with that sort of thing. But on this one, the smaller triangles go from that point to the middle. So we end up with that. Man, there's lots of triangles in all different layouts on this. Right, the next piece is basically this, but mirrored underneath like that. Although our gorge is in the way. Let's just move that down a little bit. Right, then this is actually the point where it attaches to the ground. So I think we're not actually too bad a scale there. I've done that pretty well in my opinion. So basically we end up with that sort of thing. Although, hang on, you're not there. Delete you. Okay, so the question is, it looks very, very odd. I will say that. Does that pillar hold? Oh dear. Oh dear. It doesn't hold because we have a square. Well, we have a pentagon there technically. However, I think once we start cantilevering out, that will shore this up. Although quite an unusual design if there's a big hole in the middle that, well, you would have thought they'd build it like from the pillar out. I'm not really sure anymore. All right, well, anyway, this is where it might get a little bit off gridish because basically I need to go to each node above. But I think if I do that triangle down to there, yeah, I think it looks something like this. Now, I'm not going to lie, I don't really know why, like, who came up with all these, like, it's quite an irregular looking truss. I'm not entirely sure why at the moment. Maybe we'll be able to see once we actually get some, like, a load on here with the stress turned on. We can see how all the different bits work. But for now, I'm a little bit baffled, not going to lie. Okay, so basically that's our pillar. And now we've done the upper truss. And then there's like a sort of flat truss in the middle. Now this one just does triangles. Unlike before, they're sort of symmetrical about the middle point. So they're more like that. So if we copy that every single time, we've then got 5 triangles. So that is the middle point there. And then 4, 5 like that. And then there's another one of those, which is just like a triangle on its side. So it's not like a pointy up triangle. It's just like a half triangle. And then it goes back to that. So if we just copy that, mirror it, and then paste it there, you can see how much further we need to move the gorge. We need to move it down and across. So let's just move all those out the way, wang it in there, then we can move the gorge back to the right place. And so we can just fill this in. So we end up with something like that. And then we can press play and see what happens. Oh, it does actually hold. I was not expecting that. I will not lie to you. So standing stress is 70%. Let's just have a look at what this bridge is. It's the Perrine Memorial Bridge, although technically this was the Twin Falls Bridge. But yeah, basically this wasn't strong enough to support like the new loads of like big lorries and stuff. So they replaced it with a huge steel arch bridge, like the Gorge one I did the other week. But let's turn the stress on, and if we just look at this from the front, you can see where the stress is. So down this edge here, and then the road in the middle, it's very, very stressed. Although, to be fair to the bridge, like lorries, they weigh quite a lot. It goes up to like 90%. So it doesn't actually add too much stress. It has a fair amount of strength in this bridge, but you can sort of see like it needs an arch. Like the fact this isn't curved, it's not doing a lot. Like you got the stress down there, you got the stress up the top. There's a definite orange sort of arch in terms of stress. Hence why it's been replaced with a huge gorge bridge. And you may remember earlier I was talking about the construction. Well, have a look at this photo. You can see them building it. Because it's cantilevered, they can actually build it from each pier, just adding to the middle, longer and longer. So yeah, thanks for that suggestion. Really, really cool bridge. Sorry I didn't do the modern one, but I did the original, and I think it's quite a cool bridge, to be fair. Anyway, let's give this thing one final spin today and see where it lands, although you won't.
You can't keep getting away with it!
Okay, this is a very, very cool looking bridge. We're in America again. We are crossing the Mississippi River. And honestly, when I saw the name of this bridge, I did not think it was American. So that might be a clue for some of you that know your bridges. It took 6 years to build, starting in the 60s, finished in the 70s. I mean, I'm not really sure how big to do this one, like the last one again. But I'm pretty sure I can do full-scale roads. So let's just move this out the way for now, because I don't know how long it's going to be till I start building. But we need a foundation going to, like, there-ish. The total bridge length is, like, over 2 kilometers. I'm just going to focus on, like, the main bit, the cool bit, because, like, the rest of it is just, like, foundations between, like, roads like that. Like, that doesn't count. We don't care about that. The main span is 274 meters, and that is the bit we want to look at. Again, we're going to have to use hydraulics purely for the color. But basically, I'm building a huge steel truss arch, and then we're going to suspend the road from it. So I think I might work on the grid for now, but possibly come back afterwards, because I don't really know. I mean, actually, I could try and get the number of road pieces in for, like, the number of cables. Hang on, let me just do some counting on the photo. Okay, it's got 11 pieces of road to the middle. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Hopefully I can just copy that again. That is going to be a massive span. Okay, we'll move that out of the way. There's 2 of these. I may need to do the half scale again. I didn't realize it was that big. Anyway, foundation to that bit of road. Then let's try and get an arch from there to there. So how big can our hydraulics go? Is that tall enough? I don't think that's tall enough. And that is the main constraint. I think we're going to have to half scale this one, I'm afraid. Yeah, we could do a 75% scale. I think that works. Yeah, I think that will work. That will work fine. Okay. So first up, I'm going to put the cables in just so they're all in the right place. So these just go vertically up to that line I just drew. And this is what's going to hold the road in place. The road's just going to dangle from this huge steel arch above. So I've done half. So I just copy them, mirror, wang them on the other side. Lovely jubbly. And I can remove that line, because what I need to do, I need to work out how this works. So we've got that there. That goes across there. And it looks like 45 degrees. So like that. I'll just expand these hydraulics. And then we've got our pier, which means I can put the top of the arch in if I copy to that side. So we go from that point to that point. We just sort of flatten it a little bit, because the middle is slightly shallower than the outsides. Not really noticeably though, but that looks pretty good to me. Then we'll just do hydraulics straight up like that. I mean, we can actually go, yeah, like a zigzag. So from every cable, we're just going straight up, then diagonal down to the next one until we get to the middle, because then we need to copy this to the other side. Although actually, before I do that, I should probably extend all these hydraulics and fill in these gaps above and below. So quickly just draw those in, extend them all. Right, then we've got that. Then we can copy this to the other side. Lovely. Then we can copy all of this to there. And then we're nearly there. We just need to add one more curve. So if we go from... I mean, we want to go from like the tangent point. So probably there and there. And then if we bring these lines down to there. So this straight line is tangent to this like curve, this circle. And then I can just bring all these nodes up to meet this line. All right, so with that smoothed out, that's pretty much the main part of this bridge. Will it be strong enough? I'm not entirely sure, if I'm honest. Let's press play and... oh, it is. It is. Which means I can just add a few more bits of road. If I shove them all on anchors, I can make it look very realistic. So as I said before, this isn't really the main part of the bridge. This doesn't matter. Anyway, this is the final bridge, the Hernando de Soto Bridge. And comparing it to the original, I think I did a pretty good job. It's just a shame you can't get like the cross braces in without using road. And I don't think I want to use road because that will add more weight. And look, we're already on like 90% stress. And our vehicle hasn't even made it on. If I just speed it up. Oh my goodness, that is not very good. So let's turn the stress on. Oh, you can see what's happened. These are too flat. These are way too flat. Now, there is a very ingenious way I can make this work a bit better. I can come to Blueprint, click on the lorry, and I can just reduce the weight a little bit. Now it weighs 5 polygrams, which honestly, looking at how red that is, I'm not sure if that's gonna help. Up to 99% stress. Oh, it just about makes it. Oh boy, 99% stressed, almost the entire weight. So yeah, I think in reality, I probably should have made this lower arch a little bit steeper. That would make it a lot stronger. But yeah, you can see it cost me under 500 grand. Now, in real life, this expected to cost 12 million at the time, which in today's money is 72 million. But the final price tag was 57 million, which in today's money would be 269 million quid for a bridge that's 99% stressed. I will say though, a tied arch bridge is pretty filthy in my opinion, so I think it's money well spent. Anyway, before we go, let's just head into sandbox. Let's turn on unbreakable, add a hydraulic phase, and let's see what this bridge does. Hello. Oh my goodness. Okay, so question 1, will our lorry be able to get up that hill? 2, will the ambulance stay on the truck? Question 1, yes. Question 2, yes. What? All right, look at it go. Look at it go. It's going to struggle down here, surely. No way. That worked better than the original bridge. That's incredible. Anyway, for this one, we're going to be showing an older bridge that was replaced by a newer bridge. I'll build both of them, and you guys can decide which one you prefer. But basically, I think we'll start with a 20-meter span. These are a little bit lower. All right, and basically, this was built in the 50s, but it was replaced because obviously traffic demand has grown and basically this bridge just couldn't do what it was designed to do initially. But yeah, for the main span of this, I'm going to need lots of little tiny roads, little baby roads as you might say. And then this is actually a cantilevered bridge, so that's the midpoint. So if we go from this pillar with a foundation, and we got these 45-degree nodes like that, then these connect up to that. Well, basically there's actually loads of little baby triangles, a baby truss, and then from there we connect up to that. Boosh. So we then do the same over here, so we end up with something like that. I need to actually think about how the roof of this one goes on. So I can only stretch that to there, so maybe that's as tall as I can go for the middle piece. Though actually, no, looking at this, that does connect like that, which means I can raise this up. Okay, but if we grab my curve tool, we want to go from there up to there and curve it sort of like that. It actually looks like these triangles change size along this. So, right, then I just do vertical pieces between all of these, and we end up with something like that. So if I then copy this and mirror like that, then you can sort of see this should be balanced about this middle point. If I then just copy this to the other side, realize my span isn't long enough. Always need a bigger bridge, Matt. You always need one. Then I think that looks pretty good. The question is, will it hold? I don't know. Let's press play. Oh, it does. It does. And it holds the car. Lovely. You will notice though, there's no cross beams. We can't be having that. So give me a second. Yes, these are just visual, but what are you going to do? Oh, actually, I've just realized the car smashed into it. Final destination if ever I've seen one. So what I'm going to do, I'm going to click on this car and I can actually scale this down if I use this slider. So now we've got a tiny car. So if I press play, oh, it does actually hit it. It spins it around. But yeah, I can then copy these all the way along here because these are basically the cross beams for the bridge. So yeah, some of you may call this architecture, but I'm pretty sure it's doing a job just in a third dimension that you can't see in Polybridge. But for engineering accuracy, I'm still including it. So yeah, I've slowed down the car just so we can see this for a bit longer. But this is comparing it to the original bridge. You can see it looks pretty good. Pretty similar in my opinion. If we turn on the stress and then like the original, we up the amount of traffic. I should probably, let's lower the scale of that as well. That is going to be way too tall. Ow, my bridge. No, you knob. Why would you do that? Right, I need low cars to duplicate these. So these are all the different amounts of traffic. But yeah, we should see as more and more traffic gets put on this bridge. Ooh, can you see the stress? Some of these are going very yellow, particularly in the middle. Oh, look at the stress there. And there we go. So if we slow this right down, you'll see why this bridge needed to be replaced. There was too much traffic for the cantilever beams to handle. And oh, the middle supports just get annihilated. This was actually replaced before it collapsed, by the way. They actually used explosives to collapse it. But the new bridge gets rid of this completely and basically swaps all of that steel in favor of our friend, the cable. So I think to make this somewhat accurate, I'm going to lose those foundations, but shove them back in, like down at the bottom. We're then going to come into the bridge tab. We're going to build a pillar out of steel, which is basically going to be made out of these box sections. Now, this is just to represent like a single piece, which you can't really do in Poly Bridge very well. But I like some of my favorite bridges in this game. This is cable stayed, which means I've just got to do cables from this pillar down to each road section. And like the previous bridge, this will also work in a cantilever, which basically means, can you see I've got this pivot point at the bottom? As I add more bridge to like one side, this pillar will be trying to like lean left. So if I were to just do like those down to there, because there's more weight on this side than that side, when we press play, this just falls over to the left. Hence, it's called cable stayed because the cables make it stay in place. But we basically do that to the middle. I can then copy this over to the other side. And then we should see when we press play, it is holding. Now, all this traffic, it may not work in this game. Although stress is quite low at the moment. Oh, man, look how rickety it is. Look how rickety it is. I was about to say, but it is working. Yeah, about that. Now, in a real bridge, all these movements would be like so minute. You wouldn't actually see them. It was those up there. They just got crushed. I mean, I probably could add extra steel just to shore this up. Yeah, so yeah, I've gone a bit to town reinforcing that, but I'm just trying to make it look more realistic. And then hopefully with all this traffic on, it still gets annihilated. I mean, there's one more very clever engineering thing I can do, and that is apply a weight limit to all vehicles entering the bridge. They're completely ignoring the reason for putting this bridge in the first place. But yeah, you can see now the bridge, it's a lot less rickety, and it does finally work. So we've made a bridge that increases all the traffic. A lovely modern cable stayed bridge. Yeah, and this one's slightly harder to make look realistic. If you look at the real one, there we go. This is called the Tappan Zee Bridge, which you probably wouldn't expect. It's actually in the USA. You can see I wasn't quite able to lean pillars because in this game, like the front and back, they have to be symmetrical. Hence why a lot of like the diamond cable stayed ones and stuff I can't really do in this game, which is a shame. But yeah, prove to you, cable stayed definitely better than the steel cantilevered. Just ignore the fact that all the vehicles now weigh as much as like a paper version. And I mean, to be honest, this is actually quite similar to what happened in real life. There was actually like apparently this like huge conspiracy, although not actually for this bridge, for the original bridge. But basically, like, all the bolts started to weaken on it, and it needed to be demolished. Initially, it was thought it could be left open. But yeah, corruption and drama, all that sort of stuff, it doesn't just happen in politics. It happens in bridge building as well, which I guess technically is politics, because without politics, you wouldn't have budget to build a bridge in the first place. Anyway, let's go on to the next one. Anyway, thank you whoever nominated that bridge. Remember, if you want your bridge added to the Wheel of Bridge tune, then be sure to leave a comment below. But for now, let's give it a spin, and then you guys can't see what it lands on. Right, okay, for this next bridge, we're heading to Norway. I don't think I've done any Norwegian bridges yet. But this one is actually pretty cool. It's a hybrid bridge. So it has some cable stayed features. And basically, like, you start low on one side and you end up high on the other side.
Drugs are bad. You shouldn't do drugs.
And because it's in Norway, we're doing the glacier theme. Not sure if there are penguins in Norway. I'm sure there's snowmen though, right? Anyway, I'm going to do what I did before. I'm going to do small little sections of road. So basically, we'll just copy all of those. And because this bit is cable stayed, I need to sort of mirror this fairly evenly. All right, so something like that. We got a 24-meter span. We're quite scaled up, remember. We got 45 degrees to the top. So from this point, I need to add my curve in. So we're going to go down to there, but I need to click this little padlock here to unlock tangents, which means I can then make that line horizontal with that grid, this one horizontal with up here. Then if I switch to road and say number of pieces, reduce them down, then that's nice and smooth. So when I push down to there, look at that. And yeah, this is a hybrid. So we've got cable stayed on the right-hand side. On the left, as this like drops down, this is actually a pontoon bridge. So our bridge will actually be floating on the water type thing. And yeah, it floats on 10 pontoons. So this floating bit will it's actually a bit longer than just the curvy bit. But let's just do it for that for now. How can we get something to float in here? I mean, well, what we can do, we head into blueprint mode. We can grab a round balloon. Oh my god, it's huge. How much can I reduce that to? There you go. I can shrink it down to that size. And if we shove them in the water, that's now a pontoon, right?
Really?
So yeah, basically I wanna truss this up fairly strongly. So I think I'll just do triangles underneath like that. And then if we just shove anchors on these pontoons, they're definitely not balloons, they're definitely pontoons designed for this. Then I should just be able to go straight up from all of these. Where it gets too tall, I can just do like a cheeky little muscle. And then you can't argue but say that is a floating bridge. Look, it's floating on the pontoons. So next up, we got this cable stayed bit. So what we're going to need, I mean, thankfully, there's a big rock under there because that is where our pillars are going to come out of. So if I just duplicate these up, then look, you'll see we have 2 big pillars now, which means all we need to do is grab our cables. And I think we want to do a 45-degree cable like that. So with everything marked up, I can just go to where this cable intersects my pillar, and it looks like, yeah, they're all on grid, which is lovely. Engineers love working to grids. But with all of those in, I can then take cable and literally just go up to each one, down to each bit of road. And then as with the last bridge, hopefully the road will just balance on either side so that we end up with that. We can then shove our cross beam in probably there. And then when we press play, oh, it seems to work. It seems to work. Look at that. Look at that. Okay, so that is in. And you might be wondering, well, Matt, why is this bit so high? Why didn't they just pontoon the whole lot? Well, look, these pontoons are quite close together. Trying to get a boat through there, not ideal. Hence, huge cable stayed bit to make a huge gap underneath. Meaning, as 2 huge cruise ships cross underneath, Matt and Paddy actually make it across in the G-Wagon. And the bridge worked fine. Okay, so with the stress on, how is it? Oh, man, this bridge is like so strong. This has got to be one of the strongest bridges I've ever made. But yeah, let's have a look at this angle and announce that this is the Nordhordland cable-stayed bridge. As I mentioned before, it's a cable-stayed bridge and a pontoon bridge located in Norway. And it was opened in 1994. Quite a new bridge. It carries 2 lanes of traffic and 1 pedestrian/bicycle lane. Or 1 Matt and Paddy in the G-Wagon. But yeah, not gonna lie, quite pleased with how that one turned out. I like that. I like that a lot. Norway, good job on your bilfs. I like it. Anyway, for the final time this video, let's spin up the Wheel of Bridge tune. And wow, okay, I'm not entirely sure how to do this one. This one is going to be a very, very popular bridge. Maybe the most popular bridge I've ever created. And that's because this bridge featured in Grand Theft Auto 5. So yeah, this is a California-based bridge. And honestly, I'm not sure how to actually make this one in the game. I guess we start off, it's in a huge gorge. So here's a gorge I created earlier. And basically, we need to stop our school kids from going down like that and getting clattered by a boat. So first things first, we'll just do a straight line like that. Oh, nearly ran out of breath on that one. And then we got to work out how the frig are we going to do this bridge. There's a big arch in the middle. Okay, so there's 6 of these on either side. So 1, 2, 3, 4, 5, 6. All right, so with them marked out, I think let's grab some pillars. And we can do what we did before. Just stack these up. All right, so then we know where that meets the ground. So I think from like there-ish, we cut across to the same level. I think I can do a straight line between those 2. But then we want to curve it up, and this goes way up, sort of like that. So I'll then fill that with wood, just so I have something in the right place. I then need to work out how am I actually going to do this. I think I might just try and do it all like with wooden trusses. So basically, if I try and do like the world's smallest wooden truss up here, so we do like that sort of thing, I can then copy that like all the way across. So then hopefully that top bridge, yeah, that collapses. That's good though, because that's why the arch is there, to support this road on top. Because then if I want to support the road on top, I literally can just do like straight pieces down like that. And then this road is now resting on the arch. And these ones I'll have to move to muscles like that. And these ones, I mean, oh, we're actually getting to a point where I'd love to go to that node. So it might be a case of doing like mega muscle type thing. So once this is all neatened up, it should look something like that. And then I just copy these for the rest. So I've just got 2 more to do basically. Right, and then if I'm just going to delete this side and then mirror everything so it's symmetrical. Because with these arches, you do need to be symmetrical. Right, and then hopefully when I press play, oh yes, the middle bit does hold. But wow, right, we then need some cross beams. So they go where each of these pillars connect. Okay, so that does actually look good. That does actually look good. Okay, so then the rest of the bridge is basically just continuing this truss. So let's turn the grid back on and then just truss under all of these like that. We can then just do these wooden points down to some anchors like that. And then we have a fairly spectacular looking bridge. Right, and then we end up with that. Oh man, it actually looks good. Is it strong enough? No. Okay, sorry kids, we're cutting school meals. You're gonna have to lose some weight. Right, and then interestingly, I've just been like lowering the weight a bit, and check out this middle arch. Like it rotates so much. Sorry kids. Yeah, I think if you just go down to like 1 polygram, that probably should do it. I mean, I guess the real bridge, there probably isn't this much like flexibility and stuff because it's all like one piece rather than like loads of trusses. But oh yeah, that gets us across. So the question is, do you recognize this bridge from Grand Theft Auto? Do you recognize it from real life? Because if we flash to the real one, this is the Bixby Creek Bridge. I think it's very similar to another bridge called the Big Creek Bridge, which is actually the one that I tried to build. But yeah, obviously most people watching this have probably played Grand Theft Auto 5, and this is the big bridge in there. So you'll probably recognize this one, I hope at least. And right, so this bridge we have Matt and Paddy. They're waiting to get across, but there's river traffic that we cannot disrupt. And this bridge is called a bascule bridge, which is basically French for seesaw.
You stupid English with your Yorkshire puddings and your chips and fish.
Because yes, it is going to be a drawbridge to get out the way of the river traffic. So let's start by just putting some road in to try and space this thing out properly. So we want to add some pillars. So I think we'll add one sort of there-ish. Of course, pillars need to sit on rocks. So we've got rock there. Sort of made a stronger shape there. All right, so then I got some foundations, and basically I'm building like a tower. Now I can't just cross brace these. I mean, I could do that. That is a bit ugly though. Not that I care how it looks, of course, but we do want to sort of try and make this semi-realistic looking. So if we just do that, then hopefully that will stay up. Yeah, so we've sort of made like a little window. So if we just build this up a few times, I mean, you should start to get the idea of what bridge this is going to be by now. But if I grab the curve tool and go between those and sort of come down like that, I can then fill these with hydraulics, but I think I sort of want to do that myself. So what I'll do, I'll grab cables and I'll go from each of the road pieces straight up vertically where it intersects that curve. And then I can move this curve up a bit because it sort of does that. And basically, if I do these in hydraulics, I can just connect all those together, then go straight up like that sort of thing, and then just connect this top side as well. And then all I need to do is just cross all of these over, sort of like that sort of thing, get rid of my curve, and then hopefully when I press play, yes, that is holding the road up. Love it. Right, so next up, I'll just do the same down here. So now all of that is held in place. And I can move this boat to the middle, which will probably be around there somewhere. And then I just add the sort of points. So we got that sort of thing. Now, I'd really hope you probably would have guessed this by now. But if you haven't, don't worry. Don't worry. Another clue is the location of this bridge. This bridge is in London. It was built at like the end of the 1800s, which is just insane that like stuff like this could get made. And like it's still standing. But yeah, I think something like that is good. So let's just grab all of this. Copy to the other side. Boosh. Put this bit of land in the right place. So we end up with that. And then we've just got to try and sort out this. Because as I said before, we need hydraulics. We need to get this out the way. So what I'm thinking, if we go like down here, sort of like that. Turn the grid off and press that against the side. All right, then we have a working bridge. But no one raised the drawbridge. So to actually make this raise, I've got a little contraption in here. So I'm going to expand that one. Copy that over to this side as well. And then in the settings, I just need to add a hydraulic phase and turn on the hydraulic controller. And basically, I need hydraulics to go before the boat and then after the boat as well. So if we press play... Oh my goodness! Oh no! I forgot all the hydraulics were turned on. Thankfully, I'm not a real engineer anymore. I just do YouTube now. That does make me think. If I turn on Unbreakable... Oh! Oh no! The road does not like that. Whoa! That was insane. Oh no, Man Paddy, what are you doing? What are you doing, Man Paddy? No! Anyway, what I need to do in the hydraulic controller, I need to literally remove all and then just turn on that one and that one. And do the same over here. Oh, I nearly forgot as well. I need to add a split joint down the middle and tell that to disconnect. Okay, so now, hopefully, that will just raise up. Oh, that's a little bit too high. It's waving at us. It is waving at us. And then let's just make that expand 30%. Okay, so now that raises up. The boat can get underneath. Love it. Then once the boat has come, that lowers. And then Matt and Paddy get across. Is it strong enough? Let's turn the stress on. Oh, I went up to 94%. But we just about made it. So yeah, in case you didn't guess, this was the Tower Bridge in London. It took 8 years to construct, 5 major contractors, and over 400 workers working every single day. And basically, they did like a massive competition to decide like how to solve the problem of crossing one of the busiest waterways in the world. And there were 50 different designs submitted, and like some of them are pretty funky looking. And it's just weird to think like London Tower Bridge could have looked very different. And yeah, this is Tower Bridge, not London Bridge. People often get them confused. But yeah, this is Tower Bridge. You can tell that because there's towers. And that is a very, very bilfy bridge. But let's move on to another British bridge. And this one is the bridge that I drive across the most. It's probably actually one of my least favorite bridges. At least until recently when I found out it's actually the longest bridge in the UK. So I've done a very, very long span. And basically for this one, like a lot of the bridges we have done on this series, it's just a load of concrete foundations. And these are just piled into the ground so that it's nice and stable. But of course, not much of a gap between them. So if you want to get a boat underneath, you're going to struggle. Hence the middle part of this bridge. And for this middle part, I'm going to be putting my road pieces in as small as possible. Oh, I can't get away with 2s. I can get away with 3s though. So yeah, let's just copy all of these. So basically, we got a whole lot of that. Loads and loads of different road pieces. And in case you hadn't guessed, the middle section is going to be cable stayed. Now, this one is not 45 degrees. It's sort of like, I guess, that sort of angle. And what I'm thinking, if I do, rather than doing like the 3 blocks that we've got, if I do 2 like that, then hopefully these will fit. So I'll just do a whole load of cable drawing. And then I can head back into the blueprint menu because I need some pillars. So rock underwater to support this all. Oh, I can make them big. I didn't know I could make them big. Okay, I can then do that. And then I think what I'm going to do for this one, we're just going to shove anchors like all the way up here. So we end up with something like that. I then need to copy all these anchors. Hopefully I can duplicate. Yes, I can. Shove them on the other side. And then I still need more anchors because there are cross beams. Although actually, maybe I don't. Maybe I don't. Let's head back to the bridge builder. Let's grab some road. And basically we want cross beams like... I guess if I do a box like that, yeah, that's good. That is good. What isn't good, though, is the color of these cables. It's not realistic. Again, this is one where I'm going to have to use a bit of hydraulic just for the color. So So I think what I might want to do is just draw a line, do these down to minimum length, and then fill. But once done one side, I can then just copy to the other side, and then there is another pillar over this way, so I can do that as well. So I guess we'll use the power of editing, so you can see this time lapse, whereas for me, it's just happening very, very slowly. Right, and then we grab this, we copy, we flip to that side, and then we end up with that, which looks like an absolute mess. But I think when we... Oh, no. I was going to say, when we press play, it will look really, really good and nice. Now, I think the reason that happened is because this arm isn't connected to anything. So whilst it should stay there, isn't. Oh, my goodness. Okay, I'm not actually sure if this is going to work. I thought this was going to be a nice, quick, easy one. Let's grab all of that, copy to the other side. Right, but then I think we're done. So if we press play... Oh my... What? Oh no, that's not good. All right, let's turn the speed right down. Let's turn the stress on and try and work out what is happening. So the roads are just getting like ripped apart. I think it's because in Poly Bridge 3, if you add lots of nodes, I think they actually like stretch more than like fewer pieces would. So yeah, basically you can see them, all the cables are like sagging like anything. They are not tight. Now I can turn on unbreakable though, and then if I turn the speed up, then that should maybe potentially settle. You can see, look how curved the road is. And yeah, I mean, to be honest, it doesn't really look much like the original. If we just compare that to the photo of the original, this is the Prince of Wales Bridge, it's now called. It was called the Second Severn Crossing, because you can see in the background of the photo, there's the first one, a nice suspension bridge. This one, pretty ugly in my opinion. It's not even painted, it's just like concrete. But yeah, the cables on here are meant to be like light green, but since they don't work, I think what I'll do, grab all of those, boosh, delete them out of existence, and I think we'll just bung cables in to see if it looks a bit more realistic. And then comparing that one to the photo, yeah, that does look a lot more realistic. And look at the stress, it's not even stressing at all. Matt and Paddy in the G-Wagon safely across the other side. So yeah, this bridge connects England and Wales across the Severn River, which is a very, very silty sort of area. I don't even know if... I assume boats do go up there. I feel like I've never seen a boat go up there. But a lot of the time, the tide, like when it goes out, this whole width is just mud. But yeah, this brings us to our next bridge, which isn't actually very far away from this bridge at all. In fact, the river the next bridge crosses joins onto this river, the River Severn. But right, this next bridge, it's high up in a gorge. So we need to build that gorge first. So I'll grab these bits of terrain and sort of do... I mean, it's pretty steep, sort of like that. And then on the opposite side, there is a road at the bottom that it crosses over. But then, yeah, back up a very steep gorge again. Now, this is a proper British bridge. Opened in 1864, so before Tower Bridge. So this is an old boy. Yeah, and it's over 200 meters long, which is pretty big. It's over 100 meters high. It just baffles the mind that people could have built that back then, like with hardly any sort of machinery and stuff. But yeah, this is a suspension bridge, so not a cable stayed like the last one. So this one, we will push the road into position. And then we just need to sort of try and work out where we want our pillars. If we call that the middle of our bridge, 9, 10, 11 pieces. So I think something like that should be good for the tower, which does mean I need to move my gorge a bit, because the gorge only sort of starts like after the tower. Like the tower sort of sticks out on the cliff a bit, but it's sort of more like that, I guess. So then to hold this tower up, we have pillars underneath. Yeah, like that, blocked off. I then need to copy this over to the other side, so we end up with something like that. Our huge gorge. That is not safe to drive along, Matt and Paddy. You both wait there, please. Wait there, Paddy. Good boy. Wait. So, now we need to go from there over to there, and we need to curve this down. And I think what I want to do, I want to go straight up to these, like we do with every suspension bridge we do. We'll get the vertical cables in first. And then I think what I'll do, I'll just do like 2 hydraulics between them. And again, we're using hydraulics for the color. It's not architect-like. It's what engineering used to be like back in the 1800s or something. Now, this has sort of 3 layers of, like, I think it's just iron rather than steel. But we sort of just want to grab, like, that entire thing and just copy it upwards. Although it doesn't look like it's going to fit. I could do one there and then just manually squeeze the others in the middle. And just putting these in the gaps in the middle. Right, there we go. That is quite a chunky chain. Yeah, I now need to connect these to this tower. So what I'm thinking, if we do something like that, I then just need to like copy this to the other side. So something like that. It's worth noting these do actually go like into the ground. But I reckon I can probably get away with just shoving like a pillar there. Wang some anchors in, it will be fine. I then need to delete the high cable I accidentally copied. Right, then copy this over to this side. Boosh. And then watch, because this is going to be a catastrophic failure. Oh dear. So if we just turn the speed down and then we watch this with the stress on, you can see basically there's so much weight from these chains that the towers just crumble. So what I may want to do is replace these with steel. Again, not entirely sure if this will be strong enough, but we'll see. But basically, the weight of the road, the weight of all the cables, they all just hang from the pillars. All right, so they're attached. Let's press play. Oh, no, the road breaks. The road is snapping. There's also a bit snapping up there. I think that's because these are getting, like, pulled apart. So if you think all the weight through these cables, all the roads, they're sort of, this bit in the middle is getting pulled apart. So let's steel up those bits. I'll do the same over this side as well. But yeah, the road is still breaking. If we watch, you can see it's because it's falling a bit too much. Now, I do just wonder if I were to like stitch all these cables together, because they are meant to be like one sort of piece. This is going to add more weight to the bridge, which isn't ideal, but it may stop the road falling as far. Yes, it did. Yeah, because in the middle, no, Matt Paddy. In the middle, we're only hanging off that bottom cable. The top 2 cables are just there for like visual. And as we know, if it's just there for visual, it's architecture, so it must be destroyed. Alternatively, engineered like this by just stitching it up. I'm quite concerned about the amount of weight I'm adding to the overall structure, but well, we'll see what happens. Right, okay, so that's all the cables stitched up. Now, oh, it is holding. It is holding. What's the stress like as it goes down the middle? Are we good? 99%. Oh, no. So they broke. The bridge did hold. But yeah, I think there was just... Oh, look, it's the vertical one. So yeah, I need to do the vertical up to there. Now we're all stitched together. Those top bits are taking weight as well. But I think we've gone and done it. Now, I'll be the first to admit this isn't the most impressive looking bridge. But compared to the real one, it is very impressive looking. This is the Clifton Suspension Bridge in Bristol. Now, it's actually a toll bridge. It costs you £1 if you want to get across it. Well worth it though. And basically, the famous engineer Brunel first designed this bridge, but there was like riots and stuff, so it never got built by him. And then later on, some engineers sort of took his design and sort of tweaked it a bit. And that's because he died before it was finished. And quite interesting, the first bungee jump happened in 1979, or at least modern bungee jump happened off this bridge. But yeah, I just find it mad that this was built like in the 1800s. Like, look how tall it is and stuff. Anyway, I hope you guys enjoyed. For now, I'll say peace, love, and bridges. And next time, we will return to the Wheel of Bridge tune. So make sure to add your suggestions to the comments below. I won't be so British and patriotic next time. Anyway, peace, love, and bridges. Bye!